So today we're going to look at circumcenters and incenters. These are the special intersections of the perpendicular bisector and the angle bisector. So in your notes, you see the first part here says circumcenter. So let's fill in the blanks. It says the perpendicular bisectors of the sides of a triangle intersect at one point, and it is called the circumcenter. So this is where all the perpendicular bisectors intersect. This next statement is very important. You might want to put a star by it, highlight it, whatever. The circumcenter is always equal distance from the vertices of the triangle. Okay? Always equal distance from the vertices of a triangle. Alright, so let's look and see what that means. That means from the vertice to the circumcenter, it is equal distance. So all of these segments here are equal distance from the vertex to the circumcenter. Okay, that's going to be important because you're going to have some practice problems like that. Alright? And then it says to use the diagram to list these things. List the perpendicular bisectors. So all of these that show a perpendicular box, those are your perpendicular bisectors. Make the right angles. So PD, PE, and PF. Those are all perpendicular bisectors. The name of the circumcenter where these three come together is called P. Alright, and then it asks you to label the congruent segments. So you see that the sides are labeled. So like BE and EC are equal. That's here. BD and AD are equal. That's here. AF and FC are equal. Okay? And then all of these are equal. From the vertex to the circumcenter, these three are equal. So AP, BP, and CP are equal to each other. Okay? So make sure you get those written down. Alright, so we're going to use this information to answer some problems. Alright? So the first one, let's just look at it. Because it's saying if Z is the circumcenter, then find the missing measures. Okay? So let's look at TU. He gave me that XU was 19, but if this is a perpendicular bisector, remember it bisects these two segments. So that means this part is 19 as well, and if we add them together, that gives us 38. Okay? So you could do that for all of these sides here. So VY would be half of this 34. Okay? Everybody with me so far? And then it asks you for UZ. So let's look at UZ. UZ is here. From the vertex to the circumcenter. And remember, all of those are the same length. So if this one's 21, this one's 21. All right. Now your next one is WV. All right, so let's look at that one. So WV, remember up here in our drawing, when it went from the circumcenter, it was perpendicular to the side. So here's the circumcenter. It is perpendicular to this side. So we would use the Pythagorean Theorem to find that missing side. Okay? So our missing side is about 14.7. And if we want to find TV, the whole length, then we're going to take that 14.7 and double it. And that gives us 29.4. Okay? So I want you to try the next one. It's basically set up exactly the same way. I want Miss Schaefer to pause the video and then I'll show you the answer. Okay, so give yourself a few minutes to try that one. And then let's check the answers. So this is the next one. Number 2. Check your answers. See if you got them correct. Alright, this time you had to use the Pythagorean Theorem twice because there was 2 sides or pieces that they did not give you. Alright, so let's look at it. Sorry. GD, they want to know it, but it gave you the whole length, so that was just 12. BC, they wanted this length. Since one of them was 7, the other is 7. The whole thing is 14. All right, they needed EH, but you did not have this measure, any kind of measure to give you that. All right, but we do have the leg. So we had a 7 here, an 11 here. We have a leg and a hypotenuse, so we're going to use the Pythagorean Theorem to find EH. And if you find EH, it should have been 8.5. All right, FD. Again, we did not have this measure of CD, but we do have the hypotenuse and a leg. So we can do 11 squared minus 3 squared, and it'll give us 10.6 for FD. And then they wanted CD, so that was a combination of those 2 measures, and you should have gotten 21.2. All right, try the next one. Ms. Schaefer can pause the video, and let's see how you do. Okay, so this should be the answer to the next one. Same concept as number 2, setting it up pretty much the same way. Okay? Pause the video anytime you need to. All right, on the back side, we've got incenter. All right? The incenter is the point where all of the angle bisectors come together. All right? So the first line here is angle bisector. And the incenter is always equal distance from the sides. Okay, now I want to remind you that just a while ago on the other side, we said that the circumcenter was equal distance to the vertices. Okay, so this one, the incenter, is equal distance to the sides. So that means these are all the same. Okay, that's important. So list all the angle bisectors, and so PB, PC, and PA were the angle bisectors. Your incenter is P, and then you'll see DP, EP, and FP are all congruent. They are equal distance from the sides. And then, of course, you have all your line segments that are equal. So you have AD and AF because they are equal distance. You have FC and EC. They are equal distance. BD and BE are equal distance. Remember when we talked about the angle bisector, the theorem says if you are located on the angle bisector, you are equal distance from the sides. So here's my angle bisector. This point is on the angle bisector. You're equal distance. Okay? And that makes these 2 sides equal as well. Alright? So let's look at our first example, if I can get it there. Alright, our first example is right here. So let's look and see what they did. They said if P is the incenter of the triangle, find each missing measure. So in P, they wanted to know it. So if we say that all of these from the incenter to the side are equal, then all of these are 8. Okay? Sorry if my microphone got away. In K, they wanted this measure. Okay? So let's look at NK. This measure is 8. And remember, if we have angle bisectors here, these two sides are equal. So that one is 17 as well. So if we create a right angle here, we have the legs, we need the hypotenuse. Okay? So we're going to use the Pythagorean Theorem. So for PK, we get 18.8. Right? And then LO, that's this. So remember, here is 8. We already have the hypotenuse is 13. We need this side. And if we do the Pythagorean Theorem, we get 10.2. So try the next one, and we'll check your answers. Pause video. All right, so here's the next answers. Number 2, same concept as before. I would suggest that you mark your part so that you know what everything is. Okay, it doesn't hurt to take that time. All right, if you pause the video and try number 3. So here's the answer to the third one. Okay. So what I'm going to have you do today is do some practice problems. You can work together as long as you're working, but make sure you don't get too loud. All right?